Alright, today we're going to talk about angles of elevation and depression. What this is one topic in trigonometry where we take our calculations for angle measures and distances that we've done for sine, cosine, and tangent and apply it to a practical situation. So, angle of elevation is going to be measured upwards from a horizontal line. So if I'm looking straight away, this would be considered the horizontal line. And if I look up, the angle formed with my arms here would become the angle of elevation. So down in this example here, this person is shown looking horizontally and then looks up towards the airplane. So this angle right here would be considered the angle of elevation. The angle of depression is going to be measured downwards from a horizontal line. When this happens, you're going to be at an elevated height, such as an airplane or a mountaintop or some other elevated height. So from this way, say the pilot is looking horizontally, and then he looks downwards towards an airport or somewhere to land or whatever it might be. And so this angle right here is going to be the angle of depression. Alright, so here's an example to identify angles of elevation, depression, and what's congruent and what's not. So if we look here, angle 1, which is right here, this is going to be an angle of depression. And what they want you to see is that this line is horizontal. And so is this line going this way. So what is going to happen is this angle 1 is going to be the same, congruent to angle 2, because in essence this is going to be two parallel lines with the transversal. So angle 1 is going to be congruent to angle 2. Angle 2 then would be congruent to angle 1 because it would be the same thing. Now if we look here, angle 3 is going to be considered an angle of depression because this hiker on a mountain horizontally would go here, and looking down at the cabin creates the angle of depression. If we go down to the cabin, this person at the cabin looking up at the hiker, this angle would be considered an angle of elevation. So in essence, the angle of depression and the angle of elevation are going to be congruent. So in this case, angle 3 is congruent to 4, and 4 is going to be congruent to 3. All right, here's an example. With word problems, drawing a picture is going to help immensely for a lot of students. So especially if you're a visual learner, it's going to be very difficult to figure out what this is. But once you put it to a picture, it'll make sense what trig function you need, because they're not always the same. So in this case, a surveyor stands 200 feet from a building to measure its height. So a surveyor is standing some distance away, wants to measure the height. He has a 5-foot tall theodolite, which is a measuring tool. It looks like it's on a tripod, and it is used by surveyors to measure different things. The angle of elevation from where the surveyor is to the top of the building is 35 degrees. So how tall is the building? So if we were to draw a picture, here would be our building, here's our surveyor, and we know that the surveyor is 200 feet away. So we know this distance is 200 feet. The angle of elevation to the top of the building, so from the surveyor to the very top, is 35 degrees. And again, that's measured with the theodolite. They also tell us that the surveyor or the theodolite is 5 feet above the ground. That's going to come in at the very end, and we'll talk about that in a minute. That is pretty important. So if we look right here, they want the height of the building right here. And so based on the angle we have, right, the height of the building would be considered the opposite side, and the distance away would be considered adjacent. So we're going to end up using tangent. So tangent of 35 would equal to x, the height of the building, divided by 200. And so when we take our calculator, tangent of 35 times 200, we're going to get a total height of 140 feet. Now, what we have to do at the very end, that would give you the height from here, which is 5 feet above where the ground is, in fact, because the measuring device is 5 feet up. So we have to add an extra 5 feet at the very end, which makes the building 145 feet tall. All right, another example here. So we have an airplane flying 3,500 feet above the ground and begins a descent of 2 degrees towards an airport. They want to know how many miles, this is important, how many miles the airport is from the airplane when it starts its descent. Okay, so we're going to measure this. So we have an airplane. So horizontally would be this, and the angle of depression would be this thing here. And so we know this is going to be our 2-degree angle. It's the same thing as if we were to do 2 degrees down here, previously, just a minute ago, we talked about how the angle of depression and the angle of elevation are the same angle. So if you were standing here looking up at the airplane from the airport, it would be also at 2 degrees, but it would be an angle of elevation. So what we can do based on this, in the height of 3,500 feet, they want to know how far away the airplane is from the airport. So they want you to find the hypotenuse. So in this case, we're going to use sine. So we're going to do sine of 2 degrees is equal to the opposite divided by hypotenuse, in this case, which is going to be our variable. Because the variable is on the bottom, we want to switch places with the trig value. So we're going to end up with the variable x equaling to 3,500 divided by the sine of 2. In which case, we're going to get 100,000 feet. However, if we go back here, they want how many miles? And we know that there's 5,280 feet in a mile. So for every foot, we divide by 5,280. And we get approximately 18.9 miles. So almost 19 miles away before this plane begins its descent is going to be the answer to this question. All right, the next one, we have two buildings that are 30 feet apart. The angle of elevation from the top of one to the top of the other one is 19 degrees. What's the difference in height? So what we have here are two different height buildings. So think of maybe like New York City, where buildings are pretty close, but they're not all the same height. So from one top of the building to the other top of the building, that's what we're measuring here. Okay, so the distance between them is 30 feet, and we're measuring the angle of elevation up, which in this case is going to be 19 degrees. So they want to know the difference in height. So we want this distance right here. This is what we want. So based on our angle, this is going to be opposite, this is going to be adjacent, so we're going to end up using tangent. So tangent of 19 equals x over 30. The variable's on top, so in this case we're going to take tangent 19 and multiply it by 30, and we're going to end up with 10.3 feet as our answer. All right, down here, we have a 6-foot man stands 12 feet from the base of a tree. What is the angle of elevation from his eyes to the top of the tree if the tree is 54 feet tall? So here we have a tree, and here we have the man. And the man is 12 feet from the tree. And when he looks up to the top, we don't know what the angle of elevation is. We're curious what that might be. And we also know that the tree is 54 feet tall. So what we have is we have opposite and adjacent. So tangent of x is equal to 54 divided by 12, and then you would take tangent -1 of 54 over 12, and that would give you your angle of elevation.